Welcome again. It's a pleasure to welcome you all to this masterclass for the MBA program. And I'm going to turn it over to our MBA program officer, Debbie Stubbs, who will introduce James.
Thank you very much, Robyn. I'm very, very honoured to, as the MBA program officer, to welcome Doc James W. To our online stage today. We are fortunate that James is a kind and honorary professorial fellow of Lancaster University. I'll keep my introduction brief and choose today to begin with James's call to action. There's some of his words which I extracted from a Microsoft Story Lab interview titled "How to Change the World People Think in 4 Easy Steps." If we don't change the world, someone else will. Quite good, pretty good. James is currently on the west coast of the US, and we're delighted today that he's able to present to you, our alumni, in all corners of the world. His talk on the subject of the promise and peril of artificial intelligence. I'm excited that James is here to share his expertise and his knowledge. His extensive and worldwide computer science experience is second to none. With credentials ex-FBI, ex-Google, ex-Microsoft, scientist, engineer, writer, speaker, futurist, spellcaster. He's developed computing in the cloud, and today he shares visions of artificial intelligence with all his chaotic goodness. He is sure to blow our minds with his AI, with AI being widely adopted by corporations, industry and businesses. We are all optimistic of its promises, imagining computing akin to improving the human brain. And as we've all been living and experiencing our world so differently this year, it's most relevant that James shares his insights and future thinking into AI. I'm certain we will all enjoy and learn something new today. And so I'd like to invite Dr. James Whittaker to bring his own magic to our stage by taking the mic and his camera and taking us away. Thank you.
Thank you, Debbie. That was delightful. I love it that you got my Dungeons and Dragons alignment worked in there so seamlessly. That was brilliant. Good afternoon, I guess, to all of you, or most of you. I'm assuming that many of you are in Lancaster, but you never know these days. I'm in Seattle, Washington. It's kind of early. You're going to see me drinking on my coffee, and you know what? That's just what I have to do to remain sane. I am going to be talking about AI, which is kind of weird. I never thought, 10, 15, 20 years ago, AI would be much of a thing. I mean, I grew up with it. I trained my first artificial intelligence in 1991. 1990, maybe even 1989. I might have gotten it. I might have been right at the end of the 80s, before the Kurt Cobain era, when I trained my first model. And I didn't really give it much credence to take over the world like it is. And so I always want to start with how we got here, because the story of AI being a thing is kind of improbable. We spent AI, that term was coined in 1954. Even hundreds of years before that, people have been talking about, thinking machines and robots, but it was always this kind of idea in our head that really seemed like it was going to stay in the realm of, cinema and C-3PO and robot and Terminator and all that stuff. And here we are. We have it on our phones. We have it on our laptops. We have it on our TVs. We have it in our ovens. We have it in our refrigerators. We have it in our doorbells. We have it in our security cameras. What happened? That's kind of an interesting story. So we're going to talk about how we got here. And then, what are its limits? I mean, if it's already in this short period of time taken over the world in such a rapid and all-encompassing fashion, where could it potentially go? Could we actually get to that robot, that Terminator, that HAL, that C-3PO? The answer is yes, but you're not going to understand why the answer is yes till we get to the end of that. So let's start. Follow me on Twitter, look at my books on Amazon, read my articles on Medium, go visit my website, and connect with me on LinkedIn. Any Lancaster student or alumni that tries to connect with me, it gets in automatically. Even if you subsequently try to sell me something, which generally pisses me off. I'm not going to be pissed off with anybody who's got Lancaster in their history. Cool? Let's start this. So now, if you look into the future and you see the present, you're wrong. That's not the way the future works. In fact, ever since technology has gotten its grips on the world, today has never been the same as yesterday, and tomorrow is certainly not going to be the same. And if you look into the future and see the present, you've just become Radio Shack. You've just become Blockbuster. You just become IBM. You just become Sun Microsystems or Digital Equipment Corporation. You're wrong. The future is never the same as the present. And the people who've gotten it wrong have gotten it wrong in sort of spectacular fashion. You know, this whole AI story, this whole computing story starts back in the 80s when mainframes really began. I mean, computers had done some stuff, right? They helped win World War II. They put man on the moon. They've done some pretty big stuff before then, but they really only became mainstream in the 80s when the mainframe was the tool of big business, right? It was powerful. You wrote apps for it, and every app was custom, right? There was no app store for the mainframe. They only solved business problems like payroll and accounts receivable and accounts payable. And you had to go to work in order to touch one. Right? Kids couldn't do their homework on a mainframe. You couldn't build a PowerPoint presentation on a mainframe, right? You couldn't do what we're doing right now on a mainframe. They were just these big, giant computers that solved big, giant business problems, and medium-sized companies didn't have them, and small companies didn't have them, and you didn't have them in houses either. But they sort of set the precedence. They outperformed people, right? Because this is crucial. Before mainframes, the tools of business, the tools of commerce, the tools of trade were paper and ink. Paper and ink. That's the way the world worked for generations and centuries. Paper and ink. And then mainframes changed all that, and they were so much better than paper and ink that that's when the investment came. And innovation generally follows money. And the investments in computing at the time were huge. Some of the richest companies on the planet, right? IBM, Honeywell, Unisys, Sperry, Rand, Digital Equipment Corporation, right? All those companies were some of the biggest, richest, most powerful companies on the planet. And all the other big, rich, powerful companies paid them to do computing for them. And then there was this little thing, all throughout the 80s, there's this little thing called a PC, right? Apple would talk about it. Microsoft would talk about it. Bill Gates, Microsoft was founded in 1975. Not a lot of people know that. They spent, 20 years in the woods of computing before they became, before Windows 95 came out, and they became, the end all and be all. And here's where this whole, if you look into the future and see the present thing, really begins to bite people in the ass. Because when IBM and Sun Microsystems and all these mainframe companies looked into the future in the 1980s and the early 1990s, they saw more mainframes. And they looked at the desktop computer and they said, it's a toy. It doesn't solve real problems. Look how hard it is to program. There's no tools for developers to build apps. If there's not enough memory, there's not enough storage, blah, 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 it's never going to work. And they all doubled down on mainframes, and most of those companies are dead. All those companies I just mentioned, and that's dozens, including Digital Equipment Corporation, which was one of they were the bomb in the 1980s and early 1990s. all of those companies are dead, except IBM, and IBM's a shadow of its former self. They had to reinvent themselves a few times just to cling at the edges of relevancy. Desktop computers won. And they were a toy. See, all the complaints were right. You can be right and things still don't happen. Because desktop computers were accessible. So the first thing they did was they expanded the number of people who could do computing. Because you could put one of these in your house. You could run your small business on a couple of these. You could run a medium-sized business on a couple dozen of these. All of a sudden, it expanded the user base and expanded the innovation around it too. Because software developers are like, okay, what are we going to do? We're going to write that old, custom software or that's only going to work in one business? Or are we going to write software that we can sell at Best Buy? And anybody can buy it and put it on hundreds of computers, maybe even thousands of computers. And that's what the developers did. Because they could solve new problems. They could build PowerPoint. They could build Excel. They could build Photoshop. They could build, all of those apps during the 1990s that were making tens and hundreds of millions for their companies. They could build those. You can't build those things on a mainframe. So not only did they expand the number of users, but they enriched the number of developers. They expanded developers because there was opportunity. Developers like, look at all those people using PCs. Let's go sell them some software. And they did. Because they could be at work and home, not just work. See how this world grew? And then what happened? You heard the same dumb things coming out of the mouth of Bill Gates and Steve Jobs and some of the biggest luminaries, the people who were right at the beginning of the 90s, ended up being wrong at the end of the 90s. There was this little thing called so Reader Rabbit. This is my example, right? You can't build Reader Rabbit on a mainframe. And I really believe that educational software was the thing that really sold PCs. Because humans that have recently procreated, had kids, they'll buy anything to gain advantage for their kids. Do you remember during the 90s, we had this thing called Baby Einstein, and it was basically selling Mozart CDs to pregnant women because they had convinced the world that if only that fetus listens to Mozart like 24/7, it's going to grow this ginormous brain. And it's going to be smarter than shit, and everything's going to be, we're going to have this world full of geniuses. They'll buy anything. And so Reader Rabbit, Pajama Sam, and all these things, those apps drove sales of PCs, and the mainframe, there's nothing they could do about it. But then a decade later, there was this technology on the horizon called the World Wide Web. And sure enough, Bill Gates and Steve Jobs fell into the same trap as the mainframe people who they beat. They said things like, the web is a toy. Look how hard it is to shop on the web. Look how hard it is the apps for building websites aren't as good. I mean, the tools for building websites aren't as good. It's not a rich client, right? They called the PCs, desktops, rich clients because, you can put all these features on them. And on the web, there's only a few buttons and clicks and things like that. They said the same damn things about the web that people said about their desktop computing. And they were just as wrong as the IBMs and the Sun Microsystems and the Digital Equipments of the world. The web added something, right? Mainframes were powerful. PCs were accessible. The web was connected. It's connected to other computers. That software doesn't have to sit on your machine. It can be accessible over the web, right? You didn't have to install Amazon. You just went www.amazon.com and all that software was there. You didn't have to install Facebook. In fact, you couldn't even build Amazon and Facebook for the web. Go ahead, build a dating app for the PC. You can't do it. That doesn't make any sense. And if you want to date somebody who uses that PC, just wait for them to show up.
and ask them out, right? These apps, the dating and the social and the shopping, they all require connection to remote computers. That was the feature. It allowed this social aspect of computing to start. And you could use the web anywhere, from home, from work, from home. And do you remember internet cafes? Does anybody remember? Anybody out there old enough to remember internet cafes? It used to be you go to a new town, and a lot of even the hotels didn't have, most of the hotels didn't have Wi-Fi. You had to go to an internet cafe. And you sat, of course, they weren't really cafes because everybody's so scared of spilling shit on the keyboard, they wouldn't let you have anything. But you went and you plugged in and you worked from an internet cafe. First thing I did when I traveled to a new town was look up the internet cafes in the yellow pages. This is the way the world worked. But once again, what you have is the world is growing. More people are using it because more people are finding, right? The people who didn't use Excel and PowerPoint and Photoshop, they were interested in using Amazon. They were interested in using Facebook. And, Facebook is sort of the penultimate example I want to pull out here. You can't build Facebook for a network of PCs. Right? AOL kind of tried, and it was really hard, and it was really slow, and it was really stupid, and you really couldn't expand it, right? It required the web as the platform. So look at this, just over a period of a couple of decades. Look at the change that happened over just a couple of decades. We went from nobody having PCs in the 80s to handfuls of people, thousands, tens of thousands of people having them in the 90s, tens of maybe even up to, by the end of the 90s, maybe tens of millions. And then in the 2000s, it went into hundreds of millions and then into billions because people had a reason to have one. It made sense for, rank and file people to own one. People wanted to be on Facebook. People wanted to buy stuff from Amazon. And then guess what? History repeats itself again because there was this other platform, this other technology that was emerging. And I was at Google. I was a Google engineering director building Chrome when the iPhone shipped in 2007. And before that, we had phones, right? We had Blackberries, and we had Palm Pilots, and we had Trios. That was a Nokia phone. We had Windows CE. Anybody have any of those, right? They didn't really do much. They did email, and that was about it. Right? You could get a browser, a little bitty screen, www.ican'tseemydamnscreen.com. And no one really took them seriously. And then, when the iPhone came out, there's that famous video even on YouTube of Steve Ballmer laughing at the iPhone and saying, oh, nobody will ever buy this thing, right? It doesn't have a keyboard and doesn't have all these other things. See, that's the thing. They don't get to decide. We've already got a test from mainframes to desktop computers to World Wide Web. We already have a test, right? Do they expand the market? And of course they do. And mobile phones aren't limited to home, working home in a cafe. You can have them anywhere. And they give developers something new to play with, right? You don't have to go to the web to download, to get an app. You download it and now you've got it. Google Maps. Back in the 2000s, before mobile, Google Maps was useful. Well, it really wasn't Google Maps, it was MapQuest, wasn't it? And all these other Nokia Here maps and things like that. Right? Does anybody out there remember printing driving directions and taking them into your car? Do you remember that? We did that shit. We did a lot. And at the time, it seemed like, wow, my own personal driving directions. Look, I printed them out. When was the last time you printed driving directions? And if you have recently, the hell are you thinking? It's on the phone, right? And the phone has all of these, it's environment aware. It knows it's in a car. It knows how to get from here to there. It knows, it it's aware of the other phones in the area that this was one of the first AIs that we built at Google, was an AI to look at all of the signals coming from Android phones and building a traffic model from that. How fast are they moving? Are they slowing down? Are all of them slowing down? Are all of them speeding up? Maybe the traffic jam is clear. Right? That's where that data comes from. It's all real time. And you can have one of these almost anywhere you want to go. And so, Google, of course, Microsoft didn't see it coming. They had finally gotten used to the web and, had to play catch up with Windows Mobile, and they never caught up. They almost did in England. You guys almost bailed them out. They had 10% of the market in England at one time. Not anymore. This one technology completely resurrected Apple. How did it do it? This is actually interesting. I always thought I'd come up with an MBA class if the pandemic goes away and I get to teach next fall. I'll teach a class on the turning points, right? What precisely was the capability of desktop computers that allowed them to beat the mainframe? What was precisely the capability of the web, right? What was can come up with one company that did it and talk about why? Like why? So for example, in 1998, Google was formed, and within 4 years, they beat all the incumbent search engines. They beat all the incumbent portals, Yahoo, Earthlink, MSN, all of them, Alta Vista, Lycos. There are tons of them, right? If it was a little later in the day and I had more coffee, I could name about 22 search engines that predated Google, and Google beat them all. Why? This is worth digging into. It's worth understanding. What was it? What was the one feature? What was the one thing it could do that no one else could do? And I don't have time to explain the Google one, but you know that I'm feeling lucky, that button? Google was the first one to do that. I'm feeling lucky. Google was convinced that eventually, using the power of AI and the data that they had managed to generate, one of these days, you would not even have to push a button. As soon as you typed in your search result, they would know exactly what you wanted. And that I'm feeling lucky was their challenge themselves to fulfill that. And of course, they haven't. Why haven't they? Because the AI isn't good enough? Do you believe that? That Google has not solved this problem of giving you exactly what you want? Turns out there's no money in giving anybody exactly what they want. The money is in displaying a bunch of results where half of them are ads. If somehow you could make it profitable, give a user exactly what they want, Google would do it. They already know how to do it. They're withholding that because they don't want to give it to you for free when they can make you muddle around in the ads and make bank. I mean, come on, guys. These Google execs, they've got private islands to finance, and they've got private airplanes that they don't want to have to go to an airport and deal with people like us. This costs money. But Apple beat Trio, and Apple beat BlackBerry, and Apple beat Windows CE, right? Bigger, more richer companies. Apple beat them all with the iPhone. Also, for one specific reason, I believe, was the App Store. The App Store that made it easy to put an app on that mobile phone. No one else had the App Store. Everybody else, you had to go find that app on the www.wherethehellisthat.app.com and download it yourself. Good luck doing it. Apple figured that out, and all the developers of the world were like, wait a minute. So this App Store thing, I build an app, you put it in the App Store, and there's an icon for that App Store right on the front screen. You're giving me access to the front screen, the landing page? Thanks. And they wrote 3 million apps later. It paid off. Right. What's next? This is where we are. We are at the smartphone era. And now coming down the, oh, so Pokemon Go. Pokemon Go for me is the one that really explains. I mean, you can't build it, right? You can build Google Maps for the web, but it ain't very good. You can't take the web with you without a mobile phone. Pokemon Go, build that for the web. Build that for a PC that sits still in the living room. You can. You're going to run around the park with your laptop. See, in each of these eras, there are not only giant new markets that are built, there are new capabilities, new apps that weren't even possible in the old era. Every time we build something that's not possible in the old era, we move new customers toward the new era. So what's next? If the platform here has gone from mainframes to desktop computers, to the World Wide Web to smartphone, what's that next thing that we're going to be building the apps of the future on? I think it's actually two things. I think it's other devices that don't look like laptops and smartphones. It's televisions, it's ovens, it's refrigerators, it's doorbells, it's all of these things that you're seeing now collectively called the Internet of Things. Another term you'll hear bandied about for this collection of devices is ambient computing, particularly when we go and make entire rooms and entire buildings smart. So ambient computing, Internet of Things, I don't care what you call it, but data is the other reason that this is working. Data, I talked about, turning the location data for all those Android phones out there into traffic data for Google Maps. A person isn't doing that, an AI is doing that. And it's doing it because of data. You look at each of these eras, in the mainframe era, we got a bunch of business data. In the desktop era, we got a bunch of personal productivity data. In the World Wide Web, we got a bunch of social data and shopping data and online habits data. Smartphone era, we got a bunch of location data. We got a bunch of environment data. We got a lot of data. And in 2006, there was an invention called the cloud by Amazon. Amazon did this. We thought they were building a bookstore. But Amazon, Facebook, and Google were all building infrastructure that we would ultimately start calling the cloud. Google had a cloud, right, a data center that housed all of the web search data that they used, right? Their index of the world's information. Google could have been first with launching a public cloud, but they weren't. Facebook had a data center full of all of the data that we've shared with each other and all the photos and all that stuff. They also had it organized into a data center. Facebook could have been the first company to release a public cloud. Call it a cloud because it gets bigger, it gets smaller. It's size the problem, right? Add more servers for when you get busy. Take away servers when you're not busy. Look at a set of data and say, oh, you know what? Those machines over there with more memory are better for this particular workload, or those machines over there are better for it because it's storage intensive, or those compute machines over there are better for it because it's really processing intensive, right? Handles all this, right? Google's data center handled all this for search. Facebook's data center handled all this for social, and Amazon's did all this for shopping, and Bezos was just the most future leaning of all those CEOs, and he released it's called EC2, the Expandable Collapsible Cloud, ECC, EC2, right? Expandable Collapsible Cloud eventually became Amazon Web Services. And the first public cloud, Amazon did this. So when people, you can complain about the evil that all of these companies have done, and they have. You should also remember, the real innovation that's behind all of this. And Amazon will remain one of the most innovative companies in the world if they do nothing else than invent the public cloud. It's ubiquitous, it's omnipresent, and it's intent aware, right? It knows about you, it knows about what you're doing, and of course it's universal. And the example I like to give on this is self-driving cars, because self-driving cars aren't possible without all that data. Now, mind you, it's data that the AI consumes. AI isn't programmed like software, right? There's no if then else, no, there's no programmer saying, well, display the start screen, and then if they possess this button, and if they press, and if they do that one, else they do this other, right? There's no, that code isn't handwritten by a person. Instead, these IoT devices learn from data. So let's talk about self-driving cars. Imagine writing the code for a self-driving car to go through a four-way stop or enter a roundabout. Write that code, I dare you. You can't, right? The if then else statement that you have to write for, let's say, four-way stop, go to a four-way stop, right? If everyone is stopped and you entered it first, then accelerate. Unless, there's no unless, but I'm making this up. Unless somebody else moves first, then stop, then restart. You can't do this. You can't write that if then else statement. It's way too long. And yet we have self-driving cars going through four-way stops every day. Because you don't program them to do it. Just like you don't program, you ever taught somebody else to drive? You didn't just give them a set of rules and like, oh, okay, I understand the rules, I can drive. That's not the way it worked. You taught them to drive, you trained them to drive, and that's what we do with cars. You might, tell your kid, you might be teaching your kid to drive, and you tell them the rules, okay, four-way stop, right? It's whoever's first, they go first, and they go second, but you got to watch out, you got to be careful, and they go through one, and they go through another, and they go through another, and after they go through a couple of hundred four-way stops, they've learned how to do it. They've learned how to collect that information on the fly, process it, and then react to the situation on the ground. Same way with entering a roundabout. You can't write that code. And so the machines, they learn that how to do it from the data. If you have enough data about going through a four-way stop, if you have enough data about going through into a roundabout, the car can eventually learn, okay, this is the data where the cars did it wrong and crashed. This is the data where the cars did it wrong and got honked at. This is the data where the cars did it right. And they follow the data. That's how they learned to play chess. They weren't programmed like, if the board looks like this, then move the king to rook 4. Right? No one wrote that code. What happened was you had a bunch of data, right? Knight to rook 4, all that for hundreds and thousands and tens of thousands and millions of games of chess. And the machine learned how to play. Just like these machines are learning how to drive. And not only are they learning how to drive from the data, they're sharing information with each other. One of them tells discovers that there's a road closed and informs the fleet. One of them discovers a speed trap and informs the fleet. One of them realizes there's a traffic jam and informs the fleet. And it's all based on data. All this data through the mainframe era, desktop era, World Wide Web era, the smartphone era, we are literally generating 10 exabytes of data a day. We entered the zettabyte era, that's 1,000 to the 7th bytes, but write those zeros out, it's a shit ton of data. We entered that era in 2018. There is a lot of data out there. And so it could be that the device, like, right, you know, an oven has a bunch of data on how to cook a turkey, and so it can cook a turkey. A television has a bunch of data about who watches what. And so, right, I mean, Netflix has that data, but Netflix only has that data for if you're watching Netflix, and HBO only has that data if you're watching HBO, and Sky Sports only has that data if you're watching Sky Sports. TV knows all of what you're watching. The TV is going to be the place where the entertainment is made, the entertainment battle is won or lost for the future, not the individual silos. But now data itself can be part of the platform. You don't need a device for it. Think about travel, which I used to do a lot before 2019. I haven't, 2020. So in 2020, I took 2 trips in January, and that was the only travel I did. I haven't taken as few as 2 trips since I was 24 years old. And I don't know if you can tell, but I'm not 24 years old anymore. Crazy. And so it's always frustrated me to have to go to a little screen like this and type all that shit in. From where do you think I'm starting? Where do you think, what does the data tell you? The data tells you that most of my flights start in Seattle, Washington. Almost all of my flights start in Seattle, Washington. Some of them start in Manchester, England, because I live in Lancaster part-time. And it should know. Where's my location? Probably going to start in Manchester. Why are they asking me? Why go through these layers of graphical user interface when there's already an AI for voice? I can speak to Alexa. I can speak to Google Home. I can speak to, I say Google and all my devices woke up. Why can't it figure that out? Why can't I ask Alexa, I'm not going to say the G word anymore because I want these devices to stay asleep. Alexa, book me a trip to Lancaster. And based on the data, it should understand there's no airport in Lancaster. I'm going to take the train. What route did this person take last time they went from Seattle to Lancaster? What route did all of the people, all of the data I have who have flown from Seattle to Manchester and then taken trains from Manchester to Lancaster, how many people have hit the Manchester airport and then went directly to the train station? This is all data that it has. AI is already capable of doing this if just the Expedias and the Booking.coms of the world would stop writing all of these senseless GUIs, collecting all of this information that it already has. And have a little conversation with Alexa. Alexa, I want to go to Lancaster. Great. About what time are you thinking? I don't know. Leave sometime in March, come back sometime in June. Right? Sometime that should be enough. Find where the cheapest flights are in that. Understand who I am and the data about me, and understand that, you know, the seats I like to sit in, and the types of layovers I'm willing to tolerate, and book all that for me. The data is here for this. In fact, there's a lot more data for this. There's medical data that will make machines better doctors than humans. There's legal data that will make machines better attorneys than actual humans. There really is no subject for which the data doesn't already exist. And just like we train that car to drive through a 4-way stop, we will be training that AI to be a travel agent, to be a lawyer, to be a paralegal, to be a nurse, to be a doctor. It already exists. And then it gets really interesting for the future when we consider reducing ourselves to data. We mostly are data already. Facebook looks at us as data. Google looks at us as data. But what if we really do that? All of me, my mannerisms, my habits, and reduce the world to data. This is a simulation of people walking on Mars through virtual reality glasses. You can do this today. Not all of Mars because we haven't mapped it, but we can make up the parts we haven't. And when AI meets augmented and virtual reality, now not only do you have the voice as the user interface to talk to computers, you have computers being able to modify your environment to talk back to you so that you can play chess with reality goggles. You can, while you're on your rowing machine or your exercise bike, you can be going through the Swiss Alps or rowing on the Thames or the Thames. Who would pick the Thames if they could, right? Or the Danube or someplace like that, the Thames. Now we're talking about input and output. The entire world reduced to data so that AI can process it. So let's talk about how this might play out in the next 5 minutes or so, and then start queuing up questions for me because I'm going to stop in 5 minutes and start answering those. And I want them to be good, so start thinking about them now. There's going to be a period that I call artificial narrow intelligence, ANI, where groups of narrowly defined data, right? Here's a chunk of data that represents all of the medical scans of the foot. And we will have a narrow AI that understands foot anatomy and puts a bunch of podiatrists and sports medicine people out of work. Here's a group of data that represents traffic tickets. There's already an AI for this. Traffic tickets. And this is all the data of every traffic ticket and how the people got out of it. And now we have an AI that will help you get out of your traffic ticket. You can download that one today. Here is an AI that has all the travel data and it helps you book flights, right? That's the idea behind artificial narrow intelligence. You take a narrowly defined set of data and you machine learn the crap out of it until the machines have found the patterns and have been trained to solve problems that humans used to solve. See, this is the key to AI. Software is capable of automating repetitive processes. AI is capable of automating human reasoning. Booking travel has been a repetitive process that software can do all the back end stuff. But we still needed a human to reason with you to get the best deal and to make sure that everything was right. We won't need that in the future because AI can take what software does and replace the human that used to be in that loop. So this is going to happen for a period of about 30 years. And you know, if you were around in the 90s and saw the transition from mainframes to desktop, you realized what fun that was. If you were around in the early 2000s and saw the transition from desktop to the web, you realized how much fun that was, how much innovation was going on. Same with 10 years later with mobile, and now 10 years later, the first 5 years of the 2020s are going to be amazing with people taking these large swaths of data and machine learning the crap out of it and building AI that replaces what humans used to do. The next phase is artificial general intelligence. Here, instead of tackling narrowly defined problems, we're tackling general human type problems. We're already doing this. We have an AI that plays Jeopardy, right? So the data there is all the questions and answers and quiz shows. If you live in Britain, you realize how much they love their quiz shows, right? And it's better than, it destroyed the reigning Jeopardy champion, Jennings, destroyed him. And so more and more of this, right? What does it mean to be human? What does it mean to be able to be a generally intelligent person for society? So you're going to see the wholesale AIification to intelligent, artificialification, I don't know, of things like our emotions and our facial expressions and our hand movements and our thought processes. Can we teach a machine to innovate if we give it enough data about what innovation means and enough examples of innovation? These are going to be some deep existential questions that we ask during the 2030s of our AI. And then the final period, and I don't know when it's going to stop, I mean, all of these overlap to a certain degree. And some of this work has already started now, but artificial conscious intelligence. If this neural network that we build, this artificial neural network that we build becomes complex enough, will it eventually start solving problems that we never programmed it to solve, we never asked it to solve, we never trained it to solve? Once this AGI phase of machines getting more and more human, will they pick up consciousness as a result of being more and more human? In other words, if consciousness is a result of the complexity of our neural network, sometime in the 2030s, that artificial neural network is going to be as complex as our own natural neural network. Now we're talking about coexistence with another species. These are all really deep existential questions for humanity. And one of the reasons so my PhD is in computer science, not in business, and yet here I am teaching at a business school. I wholeheartedly believe that we cannot allow this future to be left to the computer scientists. You see what we've done at Google and at Facebook and at all of these companies that have, our inventions have really done a lot of harm in the world, right? They link the mass murderer in New Zealand to radicalization via YouTube. I don't think it should be just computer scientists thinking through this future. You need to be part of this. We collectively need to think about what all of this means. Now, I have 10 minutes left to take your questions. So I think Robyn has been nice enough to curate them for me.
Absolutely. We already have one ready to go. And I have a pad full of paper here that I've been taking great notes and have plenty of questions to ask as well. So I want to begin with a question. First off, thank you. And I'll go ahead and have a sip of coffee so we fresh for us here. I want to begin with a question from Julia, who asks, she'd like your opinion or your view on the use of AI in the military. So you've talked pretty much exclusively about the sort of private sector, Facebook and Google and Microsoft. But of course, much of this technology began with military, or at least military partnerships. And if you know anything about the history of the Silicon Valley, you know it was very closely tied to military government partnerships, at least. And so I'd love to know, Julie would like to know your thoughts about the use of AI in the military. And she's thinking specifically about the recent killings of the Iranian scientist.
So I haven't studied the recent killing of the Iranian scientists and how much AI had to do with that, but certainly AI is part of the surveillance of other countries. Drones, completely autonomous drones, who have learned to fly via AI, have also have killed people. So AI has already racked up stacks of bodies. And so you take the data of a battlefield and feed it to an AI. And when you watch, I think it was the beginning of, Terminator 2, where it showed it in the future and all the exoskeleton Arnold Schwarzenegger storming up. I look at that as a computer scientist and don't see that as science fiction. I just see that as a possible future that we could implement. And the thing about AI and warfare is that the war data is not all that complex. The patterns come out pretty quick. Turns out it really doesn't take a rocket scientist to kill, but rocket scientists can be killed pretty easily. So it is a absolutely frightening possibility that, but there's always this one hand and the other hand. On one hand, and maybe it'll be machines kill machines, and we can fight it out that way. And so, all right, your AI beat us, so we will sign that treaty or whatever. but the downside of it is frightening. And so we really need to understand how to regulate this. My first step is to get you all involved and get you all asking these questions. So it's not just the tech nerds in Silicon Valley that are making these because we all seen how that went with all the other technologies that are nowhere near as dangerous as AI. And next is to help our governments understand and regulate. And, maybe what we say is that, there are certain classes of problems that we will just not solve with AI. Here's a bunch of data and we will make it illegal to train a machine on that data. That's a suggestion. Or we need to be able to build boundaries into our learning algorithms that will prevent them from learning certain things. And that is really hard because there will always be bad actors that will do them anyway. And so it's a frightening possibility. I think somebody's phone.
Sorry. It reminds me of conversations that, if you're a bit of a historian, not like me, conversations that surfaced after World War I, about the use of automated weapons, machine guns and things. And, obviously technology is always advancing, and it brings forth very difficult ethical questions. And AI is absolutely no different. I think if nothing else, it just expands the importance of that. So speaking of regulation, this is a perfect lead into this next question from Martin, who asks, there is media talk about governments taking on big tech. He puts that in quotations. What might this look like in terms of regulation about the use and misuse of data? So in other words, he's asking, what about the government's role on taking on sort of big tech? And of course, I can say it's definitely something you hear a lot about in European news. What should the government be doing in terms of regulation around data?
Well, so I'm not optimistic here. If you've ever seen any of the U.S. senators questioning, Mark Zuckerberg and Sundar Pichai and people like that, you've got to just shake your head and think, oh my God. Where did you get your education? Do you really understand technology at such a rodent level of understanding that these are the best questions you can come up with? They really need to start outsourcing this. All right, there's a New York Times columnist here called Kara Swisher. We should just let Kara do all the questioning of. We need to get smarter people. We need to get younger people. We need to get more tech savvy people in our government before we can even have a hope that they're going to be able to,
to that end, though, I wonder.
But yes, we are going to have to regulate this. There is no question in my mind. Tech should be regulated now. Facebook should be regulated now. YouTube should be regulated now. We should turn off share buttons until we really figure out, exactly how this age of misinformation and disinformation can be controlled. And so if we can't get our handle on disinformation and misinformation now, we have no hope for AI. So I think the conversation now is more about that, disinformation, and then for the future, maybe that will give me some hope that we can solve the AI part of it too.
I'm just curious, in listening to these debates, and I have to admit, I watched some of the conference proceedings with absolute sort of horror, as it was pretty clear some of the Congress people had never even used Facebook or Instagram, and
they have people for that.
Exactly. Well, I really felt like they should go call in some of their staffers to ask the questions, because at least they'd used the product before. But one of the things that struck me, though, was the language in which they were using, and that they treated data, or they talked about data, as if it was a commodity. And it reminded me of some early discussions around land and oil and sort of typical commodities that we trade, in terms of consumables. And I'm wondering, do we need to change our language or our frame of mind when we think about data to have a more intelligent conversation about it?
Well, I mean, in ways, it is a commodity, and it is the basis of the Facebook and Google fortune. It is the basis of the Amazon fortune as well. Amazon makes a small profit actually selling goods and services. That it's the way they've leveraged their data that allows them to be so wildly profitable. And we've all heard data is the new oil kind of thing. So does relate to oil, because oil isn't. If I offered you, hey, here's 10 barrels of oil, do you want it? You'd be like, what the fuck am I going to do with 10 barrels of oil? But if I offered you the energy that was extracted from 10 barrels of oil, you'd love to take that. And so it's really, the data is the raw resource. It's the knowledge that we extract from it that matters so much. And so we are all generating data. I gave that example about travel. My data, every time I travel, my data becomes part of what the travel AI now knows about how people travel. And somehow what we need to do is we need to figure out how to reward me for that. We need to figure out how to reward people for the contribution of their data into this ecosystem. And I don't know, like every time I book travel, it gets cheaper because my data is part of the solution. But that requires, and this is a discussion we can have, like how do you begin to solve this? And one thing we need to do to solve this is identity. Because a lot of the data that I contribute into the ecosystem isn't automatically attributed back to me, so that I can't be rewarded naturally. It's hard for them to reward me naturally because my data goes in and it gets mixed into the whole. And identity also makes us better players, right? There's a lot fewer trolls on LinkedIn than there are on Twitter, because Twitter, I can just go up and say, you don't know who I am. LinkedIn, you know who I am. It's linked to my actual identity. And if I misbehave in the LinkedIn ecosystem, it's going to be much harder for me to get a job. So there's a penalty for me, doing bad things. And so this whole idea of data and privacy and identity and its usage and compensating people for it with something better than just ads, right? Because that's Facebook and Google's value proposition. Give us all your data for free. We'll give you better ads. It needs to be a better value proposition. This is another talk. We could do an entire hour on how all these pieces fit together, but we certainly need to get people smarter than our elected officials thinking about it.
Fair enough. Another question we have is AI helping humans or replacing humans? In the coming years, will there be a need to take measures to avoid exhaustive applications of AI?
Yeah, I mean, it's both. Just like software is both helping humans and replacing humans. And, the people in software, you would argue, oh, well, we've created more jobs than we've replaced. And that's true, but software only replaced the repetitive jobs. AI is going to replace the creative and jobs that require reasoning. And there's, it's deeper than just taking away jobs and creating new ones. It's also, we get a deep sense of our own self-satisfaction and worth as a human from the labor that we do. There are a whole bunch of people out there that will be replaced by AI who are really actually enjoying their work and getting a lot of fulfillment and meaning from it. And so as more of those jobs get replaced, I fear for, I don't know if I fear or not, but it could be better if we do it right. But we're going to have to work out things like universal basic income and what does that mean and how to do it correctly, how to measure someone's contribution to society when they're really optional. And these are all deep existential questions. This intro that I gave you over this last hour has all been the start of 100 different conversations that we need to have about this. And these are all really deeply complex issues.
Sure. So
but we could say, I think that there are going to be places where we just have to fence them in and say, all right, this is the realm of machines. This over here, that's the realm of humans. And that conversation about what goes into which bucket is crucially important.
Absolutely. Well, so speaking of complex questions, we have a question. It's a little bit long from Debbie, but I'm going to, if you'll bear with me, I'm going to read it through. She says, much of the AI technology investment and usage has been in big corporations. How do you think the little guys can benefit through, and could this be sort of through collective action, for example? And I'll pause there to let you sort of answer that question before we get to our next part.
So I actually disagree with that premise. The one thing that the cloud did is, well, another thing that the cloud did, I was in praise of the cloud earlier, but it has allowed smaller players to have the same compute power as the big players. Microsoft and Google and Facebook, their advantage is wealth and a head start, but they can be competed with toe to toe. And you see these companies buying AI companies all the time. Why are they doing that? Because these little guys, DeepMind and these smaller, which is a UK-based AI company, they are the ones that are making the breakthroughs. And the cloud has sort of put the little guy and the big guy on a level playing field. It used to be that Microsoft was going to beat you just because it had server farms out the wazoo. They got the same Azure you got. And so I think it's really, the cloud has helped level the playing field, and I think most of the innovation is going to come from the little players. And in fact, I believe that it's not going to be Microsoft or Google or Facebook or one of these big companies that wins the AI wars. I think it's going to be a company none of us have ever heard of.
She continues on, she's writing, talking about the culture, and I think especially sort of the creative industries and the use of AI. And one of the issues I think that's been made very clear during this pandemic is that the arts world is changing and shifting. I'm just curious, do you see any trends in this shift? And are there any interesting examples that you know of how the creative industries are using AI, perhaps to maybe even help support the industry that is struggling right now?
Well, creativity is one of the hardest things to automate with AI. It's one of the things where the data is the most nebulous. What makes us, we can teach an AI to paint. We can teach an AI to sculpt, although the whole opposable thumbs is an advantage that we humans have for a while. We can teach them to do these things, but they lack the, whatever that is that Van Gogh had, whatever that is that Aristotle had, whatever that is that Wordsworth had, that might actually be the last boundary of human dominance over machines, is the creative industries. I own a brewery and a restaurant, and understanding how to maintain my profitability during the pandemic. There were no machines that could help break down my data to help, right? That was up to me to save it. And so there will always be these problems at which, machines have never focused on, and humans are going to be better at out of the block until the machines eventually catch up. But I think those creative fields are the ones where we're going to maintain our lead a lot longer than any others.
I'm sure you've heard of the AI created or computer created poetry that has come out, and I think it's kind of quite panned quite widely.
Poetry it's been panned, but poetry is the lowest hanging fruit for writing because it doesn't make any sense anyhow. And so, a lot of poems that are famous they look like a bunch of random words. And so, I think you can get lucky with a poem. Talk to me when one of them writes The Lord of the Rings,
Fair enough. Okay, well, so we have another question from Sue. Sue says, AI has recently helped us understand protein folding for the first time, which will inform vaccine development in the future. Perhaps AI can help us manage pandemics better.
It will. The only reason we have the vaccines we have, and we'll find out whether they work, I guess. We were discussing the 2 nurses in the United Kingdom went into anaphylactic shock because of so we'll see. But those vaccines are different. They're not just taking a part of the virus and just giving you a little bit of the virus so that they're actually decoded the DNA of the virus itself and just give you that. And so AI is all over that. AI was the reason we were able to decode DNA. AI was the reason we were able to go through all of that data and at such speed and find the patterns so early. And AI has been doing that with medicines, combining different medicines and thinking through scenarios that it never created the medicine. Instead of
a bunch of scientists in the lab for months, and AI was like, no, don't want to use that. That's not going to work, right? And it did it in seconds. And so the idea of AI assisting humans is probably the most palatable version of AI we could have, where, you know, there's a bunch of human doctors in there keeping it in bounds and making sure that, you know, that they understand its work. But at a fundamental level, and this is maybe this could be the final thought. I don't know how much more time we have, but at a fundamental level, we are not going to understand certain aspects of the solutions that AI comes up with. It could be in the future that an AI creates a vaccine that cures something, and we will not be able to explain how it does it. We're already to the point where we cannot explain how cars drive themselves. There are certain behaviors those cars go through, and we're just like, we don't know how to learn that. I designed an AI to count people in a room, and to this day, I have no idea how it does it. I gave it a bunch of data, a bunch of people in a bunch of rooms, and now all of a sudden it can just take one snapshot of a room and say there's 183 people in there, and I cannot tell you exactly how it does it. That's an AI I designed myself. I cannot tell you how it does it. And so that's the interesting part of this, is that AI is not auditable like software. It's auditable.
That sort of reminds me, you know, I teach organizational behavior, and one of the things that I always start with, and when I teach a module like that, is that I talk about that humans are infinitely fascinating because we are irrational and unpredictable. We don't follow the rules that computers have to follow, for example, in terms of logic. But it sounds like that's an untrue statement now.
That's right. That's not a true statement anymore. AI does not have to follow those rules. And so, you know, you always wonder why people do the stupid things that they do. You know, what drove that human to decide to do that dumb thing? And, you know, software has never been like that. Software has always been auditable. So, you know, every single hack, every single crack, every single bug always ultimately has a logical explanation. AI will not ultimately have a logical explanation. And it may be that is the clue that allows us to sort of keep it in bounds, right? The extent to which we cannot audit this AI is the extent to which maybe we shouldn't develop it in the first place.
This is fascinating. I do know we're running out of time, and as I said, I know we all have a lot more questions. If we wanted to learn more about this, and obviously for those of us who are non-experts in this, besides you and your books, who should we be following in social media, and who should we be reading to sort of keep up with the latest developments around AI?
Well, I did write a book. It's over there. I'm not going to stumble over all my gear here in this little wine cellar to go get it. But I wrote a book called James Whittaker's Little Book of the Future, which basically follows this talk and also adds things like quantum computing. And there's a chapter on privacy and security, and so there's more there. And then the references in that book are probably a good place to start for finding new things to study. But there's a ton of courses out there on, you know, Udemy and Udacity and Khan Academy, and you know, there's plenty of places to start that are just right at the end of your search browser.
Exactly. And we are all now more familiar with it, having shifted all of our education most recently to the online space. Yep. So absolutely.
This is your future. So this is my let this be my closing argument to you. This is your future. If I was in 1990 instead of 2020, right, 30 years ago, telling you, you know, software was your future, that no matter what you did, whether you were an economist, whether you're an accountant, I don't care what you studied in your business degree, software is your future. And it's true now, even more so, that AI is your future. Your job is going to be part data scientist, whether you like it or not. Just like in 1990, your job is part technologist, whether you like it or not. So learn as much as you can. You're not going to get a lot of this in the classroom because it's not caught up yet. Learn as much as you can, because this is your lot in life for the balance of your career.
Absolutely. And I feel like it's developing and changing every day. So keeping up with it's a challenge, but an interesting one for sure.
Yeah, the world stopped being simple a few decades ago.
Absolutely. We will end our session today. Thank you very much. We have one final question, and I'm going to go ahead and ask this. What UK craft beer do you think has the best taste, given that you are a beer aficionado?
I own a brewery over here that makes craft beer, and so I know the best one over here is one of mine. I tend, in the UK, I love to hike the countryside and drink at the pubs. The older the pub, the better. Three Mariners is my favorite pub in Lancaster. And every time I go, I meet a beer I like better, and they're always from the small breweries, never from the larger breweries. So drink local, travel around as much as you can, and find your own favorite, because the beer in the UK is so good that I meet my new favorite every time I go out.
Fair enough. Well, and we are hoping we'll get to see you face to face very soon, once it's safe to travel. We're all able to sort of be closer than 2 meters apart while wearing a mask. I think those days are coming. But in the meantime, I want to thank you again, Professor Whittaker, for your time this morning. It is early for you, so thank you for getting up and spending your morning with us. I want to thank everybody else for joining us, all of our alumni and our prospective students. This is just one of many conversations we have on the MBA program, and if you're joining us next year, Professor Whittaker will be coming back, hopefully face to face, and so we look forward to many more conversations with you. So thank you very much. I'm going to say have a good day to Professor Whittaker, have a good afternoon, a good night to the rest of you, and we will touch base again very soon. Bye-bye.